The statistics are shocking. Most machine learning projects fail before they even get to deployment. This isn't due to complex algorithms or insufficient data, but rather fundamental organizational problems. Today we'll establish the professional foundation that separates successful projects from abandoned experiments. By the end of this tutorial, you'll have a reusable template that mirrors industry standards. We'll cover the 4 pillars of professional ML project setup: environment isolation, dependency management, logical organization, and version control. This foundation will serve you throughout your entire ML career. Think of ML project setup like a professional kitchen. Chefs don't randomly scatter ingredients and start cooking. They have mise en place, organized stations, and standardized workflows. Your ML project needs the same systematic approach to avoid the chaos that kills most projects. Proper project structure isn't just about being organized, it's about productivity and scalability. When you follow established patterns, you eliminate common friction points that slow down development. The Python ML community has converged on standards that work reliably across different environments and team sizes. Every professional ML project requires these 4 foundational elements. Each serves a critical purpose in maintaining project integrity, reproducibility, and scalability. These aren't optional nice-to-haves. They're requirements for any project intended to move beyond personal experimentation. Virtual environments solve the critical problem of dependency conflicts between projects. When you have multiple ML projects, each might require different versions of the same library. Without isolation, updating one project can break another. Virtual environments ensure each project has its own independent Python installation and library set. Dependency management is about reproducibility and consistency. When you specify exact library versions, your code behaves identically whether running on your laptop, a colleague's machine, or a production server. This eliminates the dreaded "it works on my machine" problem that plagues many projects. The folder structure follows data science conventions developed over years of real-world projects. Raw data stays separate from processed data to maintain data lineage. Source code gets modularized for reusability. Notebooks remain separate from production code. This organization scales from small experiments to large production systems. Version control with Git isn't optional in professional ML development. It provides a complete history of your project evolution, allows you to safely experiment with changes, and enables collaboration with team members. Even for solo projects, Git serves as a backup system and lets you revert problematic changes. We start by creating a dedicated directory for our ML project. This becomes our project root where all files and subdirectories will live. Using a descriptive name helps identify the project purpose, and the template suffix indicates this is a reusable foundation. The virtual environment creates an isolated Python installation specific to this project. The MLENV name is conventional but can be customized. Activation switches your terminal to use this isolated environment instead of your system Python. Always activate before installing packages or running project code. Git initialization creates a local repository to track project changes. The gitignore file specifies which file should never be committed to version control. Virtual environments, compiled Python files, and system-specific files are excluded because they shouldn't be shared between different development setups. The requirements.txt file specifies minimum versions of essential ML libraries. Pandas handles data manipulation, NumPy provides numerical computing, scikit-learn offers ML algorithms, Matplotlib creates visualizations, and Jupyter enables interactive development. Version constraints ensure compatibility while allowing updates. Your project now follows industry-standard organization patterns used by successful ML teams worldwide. The virtual environment prevents dependency conflicts, the folder structure scales from experimentation to production, and Git initialization prepares for professional development workflows. This foundation supports projects of any complexity. This setup might seem like overhead for simple projects, but it pays dividends immediately. You'll spend less time debugging environment issues, more time on actual ML problems, and your projects will be ready for collaboration or deployment. The time invested in proper setup is multiplied throughout the project lifecycle. Tomorrow we'll put this foundation to work by loading and exploring a real dataset. You'll see how the folder structure guides data organization and how the virtual environment ensures consistent behavior. We're building momentum systematically. Each day builds on the previous day's lessons. Don't just watch. Implement this template right now while the steps are fresh. Practice creates muscle memory for this essential workflow. Tomorrow's lesson assumes you have this foundation ready, so take 5 minutes to build your template. Your future ML self will thank you for establishing these professional habits early.